Welcome to the lecture review for my CompTIA Security Plus. Here we're looking at the Guide to Network Security Fundamentals 5th edition. We're looking at Chapter 4, Host Application and Data Security. So we're getting slowly through this book. This chapter we're looking at listing the steps for securing specifically a host, defining application security, and we're going to try to get a base understanding of why we need to secure and how to secure data. So first of all, securing the host involves things like protecting the physical machine from theft, securing the operating system, and securing the applications on such system. And that could include things like using antivirus, antimalware, anti-adware, antispyware, just anti-malicious code in general. That's also things like keeping the machine up to date is a great example as well. Security controls for any device or process that is used to reduce risk. So we have to implement certain security controls. For example, for protecting security, physical security, we may decide to lock the computer to the desk. That would be a security control. Typically, when we look at security controls, we have two different types of security controls, administrative and technical. The administrative are going to be more of the process for developing and ensuring that policies and procedures are carried out, while the technical control is the control that are carried out or managed by devices. Typically, you set up an administrative control, and then the technical control comes after that. The policy dictates the technical control. There are typically 5 subtypes of controls. Sometimes these are called activity phase controls, and they're described later on. The controls are things like deterrent controls, preventative controls, detective controls, compensating controls, or corrective controls. Again, deterrent is more for discouraging. Preventing is to prevent. Detective is to identify. The compensating is to alter to the normal control. And then corrective is to lessen the damage. And then they have a example of each, which you can read. For perimeter defense, we typically have a exterior. If we're looking at physical, maybe like a building, the types of defenses could include, but not limited to, things like barriers, gates, fences, guards, motion detection devices, alarms, cameras, so forth. Though barriers, guards, and motion are the big ones we're going to be talking about, barriers could be fencing and barricades. Guards could be a human guard, or could be an electronic guard like a CCTV system. Again, we have the different types of technology and the descriptions like anti-climb, paint, collars, roller barriers, and then the rotating spikes. These are all more fence deterrents. Within our motion detection, that's going to be determining an object's change in position in its relative surroundings. Usually this movement generates an audible alarm. So we could be looking at like a visual, radio frequency, vibration, magnetism, infrared, sound. A great example is World War II. They had mines that were based off magnetism. So as a ship went close to the mine, the fact that the ship was made out of metal, it caused the mine to actually explode. Radio frequency could be glass breaking. Vibration could also deal with that as well. Internal physical access security, that could be things like proximity readers, access control, RFID card readers, access lists, man traps. It could be as simple as a hardware lock. It's about protecting the distribution systems for cabling. Again, these are just some examples of physical access security. And again, cameras could also fall in here as well. Hardware locks could be, again, a standard key entry. It could be a cipher lock or combination lock. For key management, it could be inspecting the keys regularly, issue keys to only authorized users, have them sign out keys, keep track of who has the appropriate issued keys. Maybe master keys should not have identifying marks, but they should be kept secure. Secure unused keys in a safe, secure place. Establish policies and procedures for monitoring the locks and the keys. For the master keys, maybe make sure they're stamped, do not duplicate. Change locks when appropriate. Could be after key loss or after major theft. Again, this is only parts of this. This isn't a complete list. Proximity readers, that's going to be like a RFID tag for access control system. It could be like a badge, it could be an RFID token, it could be a vehicle token, it could be several different things. But it'll be an RFID tag, essentially. It could be built in to a barcode or a physical asset tag. Access list, it could be as simple as recording of who has permission and then documenting as people enter or leave secure areas. Record times as they enter and leave. Maybe make this mandatory. Man traps, again, separate secured from non-secured areas by having man traps. Man trap typically is 2 doors where only one door is allowed to be open at a time. You'll never have both doors open at the same time. That way you enter the man trap, close the door, then that allows the second door to be open. Next, we're going to go on about physical security of cabling systems. So a protected distribution system. I cannot talk today. It's a system of cable conduits used to protect classified information that is being transmitted between 2 secured areas. Created by the DoD, there are 2 types of PDSs. Hardened carriers and alarm carriers. Basically, it's going to be the conduit, which is constructed of a specialized electronic metallic tubing, or the alarmed carrier is going to be specialized optical fibers, in that the conduit that senses acoustic vibration that can occur when an intruder tries to gain access. Again, this is about being able to protect the physical cabling so someone cannot tap into it between 2 secured facilities. We also have hardware security, and that deals with the physical security protecting the hardware of the host system. Again, locking cabinets, locks for the devices themselves. Here's an example. That way you cannot just walk off the device as it is hardwired or locked to the table. When you're talking about securing an operating system, there are a few different methodologies. Here we're looking at just one methodology for Security Plus, which is a 5-step process for protecting the operating system. First, develop the security policy. Perform host software baselining. Configure OS security settings. Deploy and manage security settings. And implement patch management. So part of that develop the security policy is it's a document that clearly defines organizations' defense mechanisms. We're going to be performing host software baselines so that we understand where we're currently at. That way we have a way to measure it. And we can also be looking at current configuration as opposed to configuration that we're going to be moving towards. Configuring the operating system security and settings. Basically, looking at the modern operating system and making sure it is set up in such a way where it is secure. It could be making sure it's updated, making sure it has anti-malware, making sure there is a update to it. Typical configuration baselines are looking at changing insecure default settings, eliminating unnecessary software, and eliminating services and protocols that aren't really necessary anymore. Lastly, enabling security features such as firewalls, antivirus, anti-malware. We also have working on deploying and managing security settings, and that's going to be the tools to automate the process for making sure that security template is out there. In a typical Windows domain, we have group policies or local policies that will allow the connections to do this. Not really the connection, but allow the systems to do this. That way, you can only really do what you're supposed to be doing, and you only have the rights and permissions to do your job function, not more than what you should be doing, if done correctly. Implementing patch management, again, making sure that your machine, whether it be a Windows, Linux, or Mac/Apple machine, is up to date. Making sure software is up to date, make sure that applications, making sure the operating system, making sure everything is up to date as it's supposed to. While patches can sometimes create new issues, typically vendors go through a very rigorous testing process before they put them out. So a lot of companies rely on the automated patch services to do this. You can manually patch them, but that's more time consuming and there leads to a greater administrative overhead. There are some advantages of taking the automated patch process, and basically it forces everything to go a little quicker. That way you can pretty much just install all updates and walk away. And yes, it may break things occasionally, but for the majority of the time, it'll probably fix things. Again, sometimes automated systems, automated patching, will break things. 5% of the time, roughly, maybe 3% of the time, where the other 95 or 97% of the time, it's going to fix things. So again, pros and cons for both. Advantages of the automated patch process is you set it and you walk away. Securing the operating system is, again, you want to make sure that things are kept up to date. We also have the security through design, things like trusted operating systems and OS hardening, making sure that the software that you're running, the operating system that you're running, is actually current, up to date, and is still being supported. For example, you wouldn't be running Microsoft XP anymore because that's so far out of date. You can secure applications or secure components through the installation of anti-malware. That could be anti-malware, and that could also include antiviruses, anti-spam, pop-up blockers, anti-adware, spyware, and it could also possibly include host-based firewalls. For example, you may have Malwarebytes installed for your anti-malware. You may have McAfee or Trend Micro or Kaspersky or Symantec or Norton for your antivirus. Again, anti-malware is not always the same as antivirus, so do keep that in mind. Antivirus looks at the viruses, and granted they are always out of date because every day there's new viruses that are coming out. The antiviruses have to have updated signatures to verify the file is really a virus. That's what I mean by they're always out of date. However, this is better than no protection at all. Pay attention to what antivirus you have and pick and choose the correct one based off of your needs. There is no what's the best for this year. It all is based off of the individual's needs. Anti-spam, typically it's going to be a way to prevent mass amounts of spam. You can create block lists or whitelists. Whitelists are the approved senders. Blacklists are the non-approved senders. And you can actually filter spam based off of this. Pop-up and pop-up blockers and anti-spyware, anti-adware. Pop-up blockers prevent pop-ups from happening. Most modern-day browsers have a pop-up blocker built in. Anti-spyware, anti-adware helps prevent the computer from being infected by different types of spyware and or adware, so you don't have a bunch of ads playing, essentially. Host-based firewalls, that's going to be a software firewall that is built into your operating system typically, or you could have it built into your antivirus. And this will help filter some of the packets or information going to and from your computer. What if we want to secure a static environment? So common devices for this are like an embedded system, which is a computer system with a dedicated function with a larger electronical system or electrical system. Things like game consoles, smartphones, mainframes, maybe an in-vehicle computer, or a SCADA type device. Again, the way that we're dealing with static environments is a layered approach. Things like network segmentation, security layers, firewalls for the individual items, making sure things are kept up to date, both software and firmware, and maybe control redundancies and diversities, especially if we're talking SCADA or computer controls for a car. Besides protecting the operating system, you also have to look at the applications running on that. So the aspect of application security is development security and hardening and patch management for the different applications. Application development for security, it deals with understanding the life cycle for development, application configuration for a baseline, that way you can see how an application is actually being secured, how it's actually functioning, and then after a patch, make sure it's meeting at least that base level. We also have what happens with the coding. Is the code for the application secure? What about the secure coding concepts? And we have very specific coding standards that were introduced. An example of a coding standard is to use a wrapper function, which is a substitute for a regular function used in testing, to write error checking routines for pre-existing system functions. Also being able to review and analyze code, but that may or may not always be allowed. Also, understanding how the applications detect errors and how they handle exceptions. Errors will be the faults that will occur when the application is running, the response and the recovery of those items when they do occur, and again, the improper error handling in an application that could lead to either an application failure or an application exploit. We also have the items for like failing to check return codes that could handle exceptions, improper checking of exceptions to return code. All of this deals with error or secure coding, making sure that you thoroughly test it. Fuzz testing fuzzing is a software testing technique that provides invalid, unexpected, or random data as inputs. For example, you have an input box that's expecting a username and you put an email address. Or you're expecting an email address and it's a phone number. Well, what happens? Normally when I talk about this, I tell people that when you're doing software development, you're doing form validation. For example, if it's an input box for an email address, you're expecting a alias at domain.extension. But you can code that so it's looking for a name, an at sign, some type of domain, and dot and extension, like, Joe at gmail.com. Joe is the alias, at Gmail is the domain, dot the extension, which is .com. So there are ways to code this for form validation. Input validation could come in multiple different ways, and when you do input validation, you actually help protect yourself from things like cross-site request forgeries or cross-site scripting. And these are specialized types of attacks that uses the user's web browser settings to impersonate the user instead of someone else. Also, you can do cross-site scripting where you can actually use additional code in the input to kind of see what you're allowed to do. It's possible to have clients perform validation, but again, giving it or trusting it to end users is not always a good idea. Client-side validation, where all input validates and error recovery procedures are performed by the user's web browser. Again, that's a possibility. That way, even before the form is sent via a web application, web browser, the website or the web browser would actually have to validate before sending. Again, you could do a form and then force the form when it's downloaded to have very specific validation functionality built in. That way, when you download the form, you're actually looking at the web browser, loading the form. You do input into the form, and the web browser may not send the form until it shows no errors. We have a NoSQL, which is a non-relationship database that is better tuned for accessing large data sets. That's non-relational. If it's relational, then a non-SQL database may not be the best option, because we want relational databases to be, well, relational. Application hardening could be things like executable file attacks, system tampering, or process spawning controls. And again, you can read the descriptions for those. Application hardening is intended to prevent attackers from exploiting the vulnerabilities in the applications. That's why secure coding is so important. Patch management, it's rare until more recently. Users were unaware of the existence of patches or where to acquire them for applications. But more and more holes are being found, hence the necessity of patch management. Securing today's data, because there's so much collaboration now, data and information must flow freely, and that data must be protected. When we're looking at things like big data, data lakes, they're all dealing with large data sets for some type of analytics purpose or process purpose. But it's mass amounts of data that's being analyzed. We have what's called the data loss prevention, or DLP, and there is a system in place for recognizing and identify critical data sets or data structures to ensure that it is protected. The goal is to protect the data from unauthorized access, unauthorized users, and again, unauthorized access is the big one. Making sure only those that are authorized have the ability to, well, do what they need to do. For example, you may be authorized to read it, but not authorized to copy it. May be authorized to read and copy, but not execute. There needs to be a way to prevent that data from being manipulated. DLP does examine the data as it resides in any of the three states: data in use, data in transit, and data at rest. Most DLP systems are content inspection. They look at the content. DLP systems can also use index matching for validation. Three types of DLP sensors: network, network, storage, and agent sensors. Network is installed on the network, storage is on storage, agent could be installed on each machine. And you can actually deploy policies so that when a policy violation is detected by the DLP agent, it can be reported back to DLP server. That way certain actions can take. Here we have, again, some type of DLP system that has both network sensors, database sensors, or storage sensors, and agents on the devices. And that way, if you try to do something that's not allowed, the DLP server gets notified. It's about being able to secure the data correctly. And that's the end of our chapter. If you have any questions, please reach out, let me know. Thank you. You have a great day.